Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Let us start today's class. Today's class, we in our channel, we are going to discuss questions from GATE exams. Okay, and today's class, our subject is fluid mechanics. Okay, so I think today's class will be definitely helpful for your AE as well as AW preparation conducted by APPSC and Telangana State Public Service Commission. Okay, so if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Please discuss with your friends the class were going on in our channel. Okay, so let us start today's class. Okay, now material is ready. Okay, so we know AE syllabus notification exam date has been announced by the commission, but AE syllabus, if we see the AE syllabus, it is framed on diploma standard. Okay, syllabus is framed based on diploma standard. But this what today's class we are going to discuss. This is the questions. These are the questions from GATE exams. So today's class will be somewhat additional information for you because negative marks is there for your exam. So keep considering this negative marks, I have prepared this class. So this class will be definitely helpful for you. So today's subject is fluid mechanics questions from GATE exams. So we will start discussing. We'll start today's class, right? Okay. Match the instruments with the physical quantities they measure. So here this is the match the following. Here heading is instrument and here it is measurement. So which instrument is related to which type of measurement, we have to check it properly and we have to select the correct option here. So pitot tube instruments are given instruments are pitot tube, Macleod gauge, planimeter, LVDT. Okay, and measurements are RPM of a shaft, displacement, flow velocity, vacuum, surface finish, area. Now we will see the options, which options are suitable for the given question, right? So pitot tube, the correct measurement is for the pitot tube is flow velocity. Okay, pitot tube, the correct measurement is flow velocity. Macleod gauge is vacuum, so we called it as accumulation. Macleod gauge is vacuum, and planimeter is used for the measurement area, and LVDT is used for displacement. Okay, so here the options are ready. A pitot tube is for, as I told you, pitot tube is for R. It is pitot tube is for flow velocity. Macleod gauge is for vacuum. Planimeter is for area. LVDT is for displacement. Okay, like that you may get questions in your exam. So like that you have to select the correct option. Next is, see, next one, streamlines, path lines and streak lines. Okay, streamlines, path lines and streak lines are virtually identical for uniform flow, flow of ideal fluids, steady flow, non-uniform flow. So the answer is steady flow. Okay, the answer is steady flow. Next, next question. In a flow field, the streamlines and equipotential lines are parallel, are orthogonal anywhere, everywhere in the flow field, cut at any angle, cut orthogonally except at the stagnation points. So, based on the four options, in a flow field, the streamlines and equipotential lines, the correct answer is cut at any angle. The correct answer is cut at any angle. We will move to the next question. For a fluid element in a two-dimensional flow field xy plane, if it will undergo translation only, it will undergo translation only. translation and rotation, translation and deformation, deformation only. So for the given asked question, the correct answer is translation and rotation. Okay, for a fluid element in a two-dimensional flow field xy plane, if it will undergo translation and rotation. Okay, next question, we'll move to the next question. Existence of velocity potential implies that fluid is in continuum, fluid is irrotational, fluid is ideal, fluid is compressible. So for the asked question, you will see the correct answer now. So the correct answer is fluid is irrotational. Fluid is irrotational. So existence of a velocity potential implies that fluid is irrotational. We will continue. Okay. See, Prandtl's mixing length in turbulent flow signifies the average distance perpendicular to the mean flow covered by the mixing particles, the ratio of mean free path to characteristics length of the flow field, the wavelength corresponding to the lowest frequency present in the flow field, the magnitude of turbulent kinetic energy. So the correct answer for the asked question is Prandtl's mixing length in turbulent flow signifies is first one is the correct answer. The correct answer is the average distance perpendicular to the mean flow covered by the mixing particles. Next we'll move to the next question. A fluid is said to be Newtonian when the shear stress is directly proportional to the velocity gradient, inversely proportional to the velocity gradient, independent of the velocity gradient, and none of the above. Okay, so here the statement in the question is a fluid is said to be Newtonian when the shear stress is directly proportional to the velocity gradient, inversely proportional to the velocity gradient, independent of the velocity gradient, none of the above. Now we will see here how we can justify this one. Okay, see, this is the somewhat explanation. This is the explanation. According to Newtonian's law of viscosity, shear stress tau is equal to mu into du by dy, where du by dy is the velocity gradient. So tau is the shear stress. Okay, so we know this one. So based on the question asked here, a fluid is said to be Newtonian when the shear stress is directly proportional to the velocity gradient. So this is the answer, directly proportional to the velocity gradient. Now we'll move to the next question. Here in this question, diagram is given. So whenever we are getting a diagram in the question, we should be in such a stage that we have to understand, first of all we have to understand the diagram. Okay, so once we understand the diagram, easily we can select the options, because we know 4 options are provided for each and every question. From the 4 options, definitely one option will be correct. So if we understand these type of diagrammatic questions, once we understand the diagram, what the author is asking from the diagram, easily we can go for the correct option. Okay, now we will see this one for this question. The force F needed to support the liquid of density D and the vessel on top is. So this is the entire setup is the vessel. Okay, this is filled with liquid, and this is the tube of area G. This is the small h is the height of this one, capital H is the height from this point to this point, and this is the frictionless piston of area, that is A. So given options here, once we see the options, GD into HA minus H minus H into A, and GD HA, GD HA, and GD into H minus H into A. Now we will see the correct answer. We will discuss the correct answer. Okay, so the correct answer here is, see here, pressure at a piston is HdG, force acting on piston is HdG into A. So the correct answer here is this one, H dg into a. This is the correct option. Okay, this is the correct option. Next, we'll move to the next question. The velocity, this is the next question. The velocity components in the x and y directions are given by mu equal to lambda xy cube minus x square y, and u equal to xy square minus 3 by 4 y to the power 4. The value of lambda for a possible flow field involving an incompressible fluid is minus 3 by 4, minus 4 by 3, 4 by 3 and 3. Okay, now we will see here. Okay, with this small explanation we will see how we can justify this one. For steady state incompressible flow, the continuity equations is dou u by dou x plus dou v by dou y is equal to 0 must be satisfied. We know dou u by dou x equal to lambda y cube minus 2xy, and dou v by dou y is equal to 2xy minus 3y cube. So if we see this condition of the continuity equation, dou u by dou x plus dou v by dou y is equal to 0. So we add this one, lambda y cube minus 2xy plus 2xy minus 3y cube is equal to 0. From this equation we get the value of lambda is equal to 3. Okay, so like that we can understand the explanation for the asked question. So here the answer is 3. Okay, next question. In flow through a pipe, the transition from laminar to turbulent flow does not depend on. Okay, see, we have to read the question properly. Here only most of us commit mistake here. See, we don't understand the important word does not. Okay, does not depend on, right? So these are the questions come under the category of confusion. Okay, the author wants to create somewhat confusion in the question. So we don't understand does not depend on, and just see the options which is opposite to that, and we will do mistake here in especially this type of questions. Okay, so that's fine. Each and every class I will be telling the same thing. We have to read the question properly. First thing is we have to understand the question. Until and unless if we don't understand the question, we cannot go for the correct option. Okay, once again I will read here. In flow through a pipe, the transition from laminar to turbulent flow does not depend on, we'll see the options, velocity of the fluid, density of the fluid, diameter of the pipe, length of the pipe. So the correct option here is diameter of the pipe. Okay, so the flow through a pipe, the transition from laminar to turbulent flow does not depend on the diameter of the pipe. Okay, so that's all friends for today's class. I think today's classes will be very helpful for your exam preparation. See students, see friends, our goal is to get a government job. Okay, so like that we are continuing our classwork daily. So think each and every class will be helpful. Each and every class will conducting in our channel will be useful for your AE preparation or AW preparation. So please, if you have not subscribed our channel, please subscribe our channel. Please support us. Thank you very much. Thank you for watching.